I'm gonna show you an example binomial distribution. So I gave you a homework. It is similar to the question which you will see soon. Use the normal distribution to approximate binomial probabilities with n is equal to 40 and p is equal to 20%. Find the probability of obtaining exactly 8. First part. Second part is 5 or more. So for this kind of questions, how are we gonna find the solution? First thing is I want to remind you, in the video you might seen it's binomial distribution. If we have it says binomial probabilities. If we see this, what we will use? We are gonna use the two formulas. Mu is equal to n times p and sigma standard deviation equal to square root of n times p times 1 minus p. Okay, so let's do our first one. A, exactly 8. Exactly 8. So what do we mean by exactly 8? We will come to that soon. Before that, let me find, first of all, do I know n? Yes, n is 40. Do I know p? Yes, 20%, which means 0.2. What about 1 minus p? It is 1 minus 0.2, which is equal to 0.8. So these are what we know. From these, can I find mu? Yes, mu is equal to n times p, which is 40 times 0.2, 40 multiplied by 0.2, which is going to give us 8. And sigma is equal to n times p times p, 1 minus p. So this is n is 40, p is 0.2, and 1 minus p is 0.8. So when I do this, I got approximately 2.53. These are what I have for now. Mu is this, mu is 8, standard deviation is 2.53. So when I ask you a question exactly 8, which means that as you know, as I showed on the video also, when you connect the histograms, right, you having a normal distribution like this. So when you are doing this, you can see that, for example, let's see, our mean is 8, right? 8 is surrounded by the this is the 8 histogram for this 8 part is over here. The borders of this is 7.5, right? 7.5 to 8.5. So what we are looking for when we say exactly 8 is the area of this histogram. Okay, the histogram at 8. And we know that 8 is my mean. Therefore, I can easily find the area of this part of the histogram, this part, using my formula. So let's go to the next page and try to do this problem. So in the histogram, what I am saying again, in the normal distribution, my mean is 8. Sigma, what I found was 2.53. And I am looking for the area of this parts. So let me do this one better because of this is like this, right? And this is my mean. So it is like this. And I'm looking for this area. Okay. And I know that this histogram starts from 7.5 and at 8.5. What do I know? I have a formula. Z is equal to x minus mu over sigma, right? in our book, we have the area Z table, and on the Z table, it says that the Z table in our book is giving us the area between Z to 0 over here, Z until the mean. Okay, so if I use this formula either with 7.5 or 8.5, I can find the half of the area of the rectangle here, the histogram piece. Okay, and I know that in normal distribution it is symmetric. These pieces are symmetric. So if I find either this area or this area, I can multiply it by 2, and then it's gonna give me the whole this area of this histogram. So let's do this calculation. So what am I gonna do? I'm gonna use you can use 7.5. I just want to choose to use my x is equal to 8.5, mean is 8, and divide by the standard deviation, which is 2.53. When I did my calculation, I got let me see, I got approximately 0.2. And then what I will do, when you look at on your Z table, right, you will see 0.1, 0.2, and you have 0.0 and 0.1 and so on. Okay, and this value over here, what I see was 7.93, okay, percent. It is not written 7.93%, it is written 0. Let me see again. At 2, I have 0.0793. Yes, this was the number. And this is in terms of percentages, 7.93%. And what did I say? This part, this is the area of, this is the area of this half area, half part here. Okay, this part is 7.93%. And this part is also, since the symmetric 7.93%, all you need to do is 7.93 plus 7.93% is going to give you 15.86%. All right. I want to do one more question, which is the part B. Part B was saying 5 or more. So let's go and do the histogram again. On my histogram, I have mean is 8 and 5 is before the 8. So I'm looking for 5 or more. As we said, 5 is having this histogram, right? So we are gonna, our starting point is gonna be border of this histogram, which is 4.5. Okay, which it says 5 or more, which means 4.5 or more, because of 4.5 is the starting point of the histogram, which includes 5 in it. So we are looking for the area of this part. So as I said, our Z table is giving me the area between the mean and the data value. Therefore, I'm gonna be able to find on the, let's see, I'm gonna be able to find this area using the formula. And I know that normal distribution is symmetric, so this part is 50%. Okay, if I find this part and then add it to 50, I will be done with this question. So what I will do is, again, Z is equal to X minus mu over sigma. X is 4.5 minus mu is 8, 2.53. So Z is equal to 1.38. And again, when I look at my Z table, I see that 1.38 negative, actually, because of this is going to be negative. Doesn't matter negative or positive. Still, you can look at 1.38, and I got 1.38 is equal to 41.62. So which means this part is 41.62%. So when I add them up, 41.62 plus 50%, I ended up 91.62% probability of having 5 or more. All right. Next one I want to talk about is applying the central limit theorem. So you will see a question. You will see questions with the central limit theorem. Let's remember central limit theorem. With the central limit theorem, the sample size must be greater than 30, right? And with the sample greater than or equal to 30, and standard deviation is gonna be let me write it down here. N must be greater than or equal to 30, and standard deviation is gonna be sigma over square root of n, and we are gonna use the same mu value. Okay. We are collecting, for example, let's look at this question. You might remember this. A machine cuts pieces of silk material to an average length of 1000 millimeters. So average length is 1000 millimeters. With standard deviation is 12 millimeter. Between what two lengths would we expect to find the middle 95% of all the sample averages, assuming sample size is 36. So since sample size we are talking about, right, n is equal to 36, it is more than 30, so we can use the central limit theorem. And in order to do that, first of all, I had to find a sample standard deviation value, which is sigma over square root of n. What is sigma? Is given in the question, 12. Square root of n is sample size, square root of 36. So it's going to give me 12 over 6, which is equal to 2. So now my mu is equal to 1000, sigma x is equal to 2. And let's understand the question. We have lots of pieces cut, right? But we are collecting the sample size of 36, all right? And for this one, my mu is 1000, and this is my mu, and sigma is equal to 2, all right? And what are we looking for? The important part, middle 95% of the sample. So we are looking at the middle 95. So this is 95%. Okay, whole thing. We are looking at these values. X1, what is this? What's this X2? In order to be able to find that, so it is asking me to find the middle 95%. What on the Z table, what we have is only from the mean, right? Let me delete this part. Only from the mean up until this point, we can find the area, or from the mean till this point. And we know that this is symmetric, right? This whole thing is 95%. We know that. So if this is 95%, this part, 95%, the half of it is gonna be, what is that, 47.5%, and this part is 47.5%. So what does this tell me? This is telling me that the area what I have is 47.5%, let's write it down. Area is 47.5%, which means 0.475. Okay. I have the mu is equal to 1000 and sigma is equal to 2. Sigma x is equal to 2. Therefore, what I will do, I will work backward. I will look at on the body of the table. And when I look at it, I'm searching for 0.475. And exactly 0.475 coincidence is located on the z table. And what is the corresponding z value for that? We will go backward, and I found 1.9 and 0.06. At the intersection, I got 0.475. So for the 0.475, my z is equal to 1.96. Okay. So when let's write down on our formula, z is equal to x minus mu over sigma, right? 1.96 on the so these values is negative 1.96 and this one is positive 1.96. All right, so let's find the positive part. So it's gonna be what? X minus mu is 1000 divided by sigma is 2. So when I do this calculation, I got x, when you do cross multiplication, 1003.92 millimeter. Okay, that is the data value for this part, which is 1003.92. And this one, how are we gonna find that? What we will do is we are gonna use negative 1.96 equal to x minus 1000 divided by 2. Let's do the calculation. When I multiply this 1.96 times 2, and when I added the 1000, I got 996.08 millimeter. So this value is 996.08. So this concludes that we can expect between 996.08 and 1003.92 is the 95% of all the average samples in the middle. Okay.